then I will hand it over this stage to our superstar, Albert. So I will start with the presentation now. Perfect. So as you all must be aware that this session is on the learn the fundamentals of AWS. So first of all, I would like to welcome all of you in this session with me and Albert, who is Director Curriculum in Masai School. And you will be going to learn a lot of things from him. A lot of you must be, aware about him. You must have learned from him. So it will be a very insightful session for all of you. I would like to start this session with two very important words. Thank you. Thank you for taking out time and joining this session. Thank you for believing in Masai School. And I can promise that if you are spending your time in this session, in this presentation, it will be worth spending your time. Talking about Masai School, so this is our founding team, Mr. Prateek Shukla, who is our CEO. He is an alumnus of IIT Kanpur. And then we have Rupul Dev, who is our CTO and head of technical curriculum. He is also an alumnus of IIT Kanpur. We have another co-founder, Mr. Yogesh Bhatt, who is SVP and head of holistic development. He is an alumnus of IIM Bangalore. So we are a 21st century coding school where we help the student, where we help the untapped talent, which can be from CS background, non-CS background, folks who are having passion for programming, people who want to change their career or restart after a break. How do we do it? Very simple. We build industry relevant school skills. Student need not to pay us anything till the time they are hired, and we focus on the holistic development of a student. Now, what is the output? What is the result that they get? They get in-demand jobs, which can be full stack developer, front-end developer, back-end developer, data analyst, and a lot more profiles, right? The companies that are hiring with us currently are product-based companies, service-oriented tech startup, large IT service company, and a lot more. Now, I would like to hand it over this stage to the person for whom you were waiting for a long time. Over to you, Albert, and looking forward to learn a lot of things in this session from you.
Thanks, Prashant, for the quick intro. Hey, everyone. So excited to be here. So we chose a specific topic around fundamentals of AWS. So actually, before I want to start, I want to just check with everyone. Does everyone know anything? Like, do you know programming, or have you done something towards programming before, or is the first time you're coming out of interest? I think if you can message that in the chat box, it'll be great. In the meantime, I will share my screen. Okay, great. Although I have not got a response from people, so if you can, I think put in a message, I think it'll be great. It doesn't matter; it's okay if you know or if you don't know programming, that's fine. This is just out of curiosity. I just want to know if people are aware of what programming standards are, because I think it'll be more useful in those cases as such. But irrespective, we are going to go over and kind of do a small teardown of AWS and so many of the services they provide. But I think this is a term that a lot of people would have heard over the last decade, or probably last 10, 15 years. Someone would have probably said, oh, things are in the cloud, or maybe our applications are deployed on the cloud across different continents and countries as such. So this is a term that gets thrown out a lot when it comes to technology, when it comes to app development, your web applications, or any kind of applications out there. We tend to say everything's on the cloud. We are all serverless, there's many things like that. So what really is cloud? Fundamentally put, cloud is nothing but it's actually just a computer on a network. Okay, we call it cloud because we can't really access it, or we don't really have to care about it, but it's basically in some data center, some large rooms which you are given access to, and you can basically store information. So it's not actually anything regarding actual clouds, but it's just a computer which you can actually access directly. So and this is how probably a server room might look like when it comes to, it could be an AWS, could be GCP, which is Google Cloud Platform. AWS is Amazon Web Services, by the way. So a lot of these things are large data centers. India has probably 3-4. Mumbai, there's a data center in Mumbai. I think Hyderabad has, and I think probably 1 or 2 more locations they have. So Amazon invests in large data centers so that data could, like, as individuals who use your AWS services, can have easy access in those areas. So this is just an example of all the different AWS data centers which exist. You can see in Mumbai, for example, it is there since 2016. And there are many active locations, almost 30 regions they support, and many zones out there. So this gives you a high level perspective of where all AWS service centers or data centers lie. And why is this important? Well, because you really need to understand how data actually flows. Because if you're trying to access something which is there in the US, it still takes time. It still takes 150 milliseconds or something like that, right? Because we may feel that everything is very instant in this age, right? So we may feel everything is, yeah, I think I've also enabled chat for everyone. So I think I just saw a message saying chat is disabled. Yeah, you can also now use chat. Yes, so that explains why people haven't been responding. Great. So, so when you try to connect to something which is quite across all the way to US, it takes a bit of time. There's a latency or a ping involved. So when it comes to cloud services, a lot of these companies tend to deploy these services closer to the users and actual people use your services. So it makes it faster for people, let's say in Mumbai, or people within India. So there are many availability zones and geographic zones which AWS has invested in. And couple of things why should we think of AWS or some cloud services actually to use instead of setting up our own networks? Because if you think about it, if you were in early 2000s or before that, even in the mid 90s or late 90s, if you had to set up a company and start an internet company, you had to know networking, you had to know data centers, you had to actually set up your own network infrastructure and run it. And it becomes hard to actually maintain and manage and scale up that business. So with the rise of cloud computing, we are still, one of the biggest questions were around security, scalability, availability, a lot of these things. But all of this have been proven that you can achieve all of these things that which were concerns initially. So a lot of people don't initially think about security, but a lot of the cloud service providers are built on top of security and we'll come to this with a certain role that we talk about, something called IAM. And so there's security, scalability. Scalability talks about, let's say, do you have 100 users per day or do you have 1 million users per day? So depending on that, you may need to have different services that you use as such. Availability is very interesting. So availability is the amount of time that that AWS promises that they will ensure that your systems are running. For example, because we just mentioned that computers, you're just accessing a computer. What happens if the computer shuts down? What happens as power failure at a data center? Maybe some of you would have read some news recently that there was a data center which got fired, and because which they were shutting down and doing a lot of things. And there was some downtime with other services across. So when it comes to cloud service providers, one of the major things that they claim is that they will provide you with 99.99% availability. What this means is that over a year, this will translate to probably a downtime of probably less than a day, I think. I don't exactly recollect, but there are some 3.5 days for, I think, 99%. So you can see it's just basically 10 hours of downtime, which they ensure that it won't go beyond this. But they also mention if it goes beyond a particular thing, they will actually refund some money in some areas. So flexibility allows you to choose different services, plug and play within the system. Performance is very interesting term. So performance basically says if you're able to scale up your systems and improve performance on the go. So there's a lot of on-demand performance that you can actually gain. Like, let's say you want to increase your RAM, right? You can just like do that very easily. So a lot of things with performance also you're directly able to manage. Having a global footprint, this allows that you'll be able to serve customers across the globe with the fastest speed. So there's something called edge computing, which basically means that your data will be available, your websites will be available for users in the closest centers around them. So which means latency will be reduced. So that means they'll get their data faster also. And the final thing is the number of services. There's actually over 200 services that I checked. I think today I just checked it. They have more than 200 services available within AWS. And we use a lot, by the way, but even our organization, we use a lot, even like machine learning algorithms, we are able to just directly tap into it and kind of work on it. So let's start breaking down what AWS and these regions mean, right? Because we looked at all the continents and we saw there were regions involved. Now, what happens is that a region describes like a location, could be, let's say Mumbai, right? So we would generally call it AP South 1. So within that, we'll have a couple of locations. So we say AP South 1, AP South 2, AP South 3. So we tend to have multiple availability zones within AWS or within a region. Why? Because what happens if one of the data centers has some fire, or maybe there is like a flooding, or maybe an earthquake happens for whatever reason, right? Maybe flooding happens. We don't really have control over it. In these cases, you need a different zone also. So what AWS or generally what people tend to do is you tend to have 2 more backup. So there are a total of 3 copies that are generally being made, so that if one is down, you still have another backup running to ensure there's no loss of data as such. So a little more detailed diagram you can see here. Within an AWS region, there is an availability zone 1, availability zone 2, and there's an availability zone 3. And these are basically the data centers within that, right? And you can see this is just an example of how they would probably design their own data centers and how they connected to each other. They would probably be kept in different zones, floodplain zones, which means that if one place is flooded, it's not necessarily the other one will be. They'll also probably keep a power supply so that there's backup generators and a lot of things which ensures that power outages are not there. And they'll also be in a way that they're directly connected to each other as per requirement as such. So a small example of how they try to go about ensuring that they are making their systems available to all of their users all the time. So I've also now gone and made a small diagram to kind of explain how, when you work with an AWS, how does it give you access to all of these services that they have. So from a top level, you have something, you can create an account. So I, as an organization or as an individual, I can go create an AWS account. Now within, let's assume that I'm an organization, let's say Masai School, right? I get to create users or accounts through this. And there is something called IAM, which comes here. Okay, so this is basically helping you with identity and access in AWS. And this is called identity and access management. So which is called IAM, but we call it IAM. So if you really think about it, it says I am someone, right? So that's how I think about it. So IAM is basically an identity and access management. So these can be attached to a particular email ID or a user. It can also be specific tokens that you can access it with. And this can have access to different regions, different zones, different areas. You can define those access as such. A lot of people don't tend to get into details of IAM a lot, but it's a very fundamental part to ensure that your services are secure and you're not giving too much access to someone by accident. So IAMs will have access to all regions across. You can define what kind of access you can give them. Now, what happens is that some of these services that you use, some of these things that you use with, works on a very global level. So if you look on the right side here, you will see that there is a global level which is mentioned there. So there are things like IAM, which is identity and access management, which works on a global level. There are services like domains, right? Domain names. You can also have domain names registered through AWS. You can generally your billing also kind of comes through your AWS account. So these are all global in nature, and it will be across your entire organization across the globe. So it's not region dependent or anything. But there will be some services which are only accessible in certain regions. Okay, so for example, storage. If you want to store information, it will be stored in a certain data center or in a certain region as such. So some of it will be across a region. And let's say there's something called an S3 or a storage service. This is actually accessible in a region, which means it will be available in all the 3 zones also. Okay. Then comes other services like you have server. Server is nothing but a computer, or it could have a database. All of these are on a zone level. So you can have one server in one zone. There'll be like one computer that you can have access to. It may not be available in all the 3 zones because there's one server that you're working with. So that will be a slight difference. So there will be services which are global. There are services which are region based, and there is services which are zone based. So which is why I have also created this line, this structure here. This is regions and storage. This is on zone level, like servers and databases, or some of them. So depending on the service that you go to, this is probably one thing you may need to first look up also to understand, is it on a zone level or not? Okay. So I'm going to touch upon some of these common services that you will hear about from AWS. These are all, you might think these are very complex names, but these are very simple names. They've just given acronyms so that it's easy for them to understand what it's called. So one of the most common things that you might use with AWS is something called an EC2. An EC2 is nothing called Elastic Compute Cloud. So there's 2 C's, so it's called EC2. Okay. It's nothing but a server. So a server which you want to access and you want to host a website or run an application on, it's just a computer on the data center. So this is called EC2, and Elastic means that you get to make it bigger or smaller, up to you as such. So you get to choose if you want to scale up that server or not. So this is one of most fundamental pieces that AWS provides. There's something called an ELB, which is called a load balancer. This is nothing but a way. So what happens is that when you have many servers running the same application, let's say a company like Facebook or some services which need a lot of users. Let's say you have 10,000 or 1 million users on your system. There will be a point that one server may not be able to manage it. So you need 3-4 servers to manage the load. But how does a user know which server to access? So this is where a load balancer sits in front of your servers and say, so if I were to draw it, this is your ELB. So you can see there's one server here, and then there's an arrow which is coming out of it, right? So this is actually your web server that you have. And when a user tries to access it, first it will go to 1. Then the second user, when they access it, it will go to 2. The third user who accesses it will go to 3. And the fourth one will go back to 1 again. This is a simple example. So all it does is it balances the load. That's why it's called a load balancer. Very simple. So you just need to understand what the terms mean. Okay. Then you will have a better idea of what where we're going through. So we will do a small exercise towards the second half, where we actually take up a small web application and then scale it up, and then show how AWS works over there. Another common service is called an S3. This is like a storage service. So it's called a simple storage service. So that's why it's S3, simple storage service. So it's basically to load any kind of assets or static files. It could be images, it could be your website, like any HTML, CSS, all of these information, even your, let's say, some information which is public in nature, we generally tend to store in S3. If it's private also, we can. We tend to keep protected values also, where we need to sign it first and then we can access it. But do note, if you don't put correct permissions here, you can end up leaking a lot of private data through S3. So it's important that you understand the rules if you're working with S3 later. Another service is called an RDS. This is nothing but a relational database service. So AWS allows you to host a MySQL or any kind of relational database service on that. And you can directly access these values or database through AWS itself. So you don't have to store it inside a server. So we generally try to have stateless architecture or stateless web servers. So we tend to isolate the database into a separate instance itself. So we generally use RDS for that. Another useful service is something called SNS. There are 2-3 more which is associated to it. There is SNS, there is SES, and SQS. This is nothing but a simple notification service. How many of you get these messages on a daily basis from Airtel, Jio, or like different companies saying, hey, this offer is there, or maybe this is your transaction. When you withdraw something, you get a message instantly, right? So all of these are actually driven through systems like SNS. SNS is a little more expensive than other systems out there. We actually moved away from SNS, but SNS but it allowed us to implement it within like half an hour or 1 hour or such. So it was easier to set it up, but it's a little more expensive. We eventually moved away. But there is something called SES, which is simple email service. So you're able to send emails as such. There is something called SQS, which is called a simple queue service. So what happens when you have to send emails to 1 million people, or maybe you want to send a SMS to 1 million people? We can't send it sometimes immediately to each and every one. So what happens is that we queue these updates or notifications one by one. So we generally use an SQS or a simple queue service, which will push this information into a queue. And the queue will basically keep working on it. Like it will send 50 users one by one. So there are 2 more like complementary services around SNS also that works. But I'm just highlighting some of these services out there so that you have an idea of what it does. Right. So let's actually try thinking of a basic application, then kind of scale it up. So I don't know how many of you have probably built web applications or anything out there, but either way, you should know how a website works. So we'll kind of break down how a web application works and then kind of explain how we can scale it up. So this is getting into a little bit of system design also, but it's important because essentially what system design we do is essentially what AWS also provides. So this is a small example of how a web server can end up working. So you can see here that these are users. So this could be when you went to masaischool.com, you try to access it from a mobile or a laptop, right? Now, what happens when you type in masaischool.com on the browser? Well, this is actually a very nice, interesting interview question also. What happens when you type a URL? So what happens is that you actually hit this DNS, which is called a domain naming system. And how does masaischool.com know where to go or what to show you, because that's just a name, right? So what happens is that you map information regarding your IP address of the server of whatever application you want to a DNS once you purchase the DNS, because the name is kind of real estate on the internet. So you want to point it to somewhere. So DNS is nothing other than a way to map a URL to a certain server. So once you do this, you have an IP address, it returns that IP address, and then you are able to access this web server from there. And the web server will tell, hey, you're trying to access masaischool.com. This is the website. It will respond back to you. So this is a very simple a diagram that explains how a server can work and how a web application can be done. But what happens if we want to store some information, like you want to have login credentials, you want to store information in a database? So we can add a database layer to this. Right? So now, when you hit an DNS, it will respond back with an IP address, let's say 6.3.25. Whatever. There's an IP address associated to the computer, and that you're accessing. But this web server will also have access to a database now. So if you want to, let's say, make, let's say you go to Facebook, right? And you create a posting, or maybe you go to LinkedIn and you create a post. So it is actually making an entry to the database. You're making a CRUD operation. A CRUD operation is nothing but create, read, update, delete. Okay. So you're able to create this CRUD operation and kind of add something to the database. So this way, you are able to work with an application which is interactive in nature. Now, what happens after you add a database? Well, what happens, because let's assume your application is becoming larger and larger, you have many, many more users. So you have two ways to scale your applications. There are two things. One is vertical scaling, and there is horizontal scaling. A vertical scaling I mentioned before, it's to increase the RAM, increase SSD, increase CPU, all of that. So you can make it from an 8 GB SSD, 8 GB RAM to maybe 16 GB RAM or 32 GB RAM. Or you can increase the space from a 256 to a 512 GB. So, but there's only a limited, a maximum limit you can achieve with vertical scaling. So over time, people tend to go through horizontal scaling. So they're okay with having multiple servers rather than one single server, which is still a single point of failure. So let's go add a couple of servers into our system. So we add two servers now, right? We have web server 1, web server 2. But how does the user know which server to hit? Well, this is where you can use a load balancer. Right? You now, instead of the DNS pointing to a web server, it will point to the load balancer. So the load balancer now knows which server to access. And even if now one of the servers is not working, it will only send users to the first server. Does that make sense? So once you have a load balancer and multiple servers, eventually what will happen is your database, or before database, I think we can get into a file storage. So how do you share files now between these two web servers? Let's say you have some static files, you have videos that you're uploading, all of that. So when you're on Facebook or LinkedIn, you might post an image or a video as such. We don't store images and larger blobs or videos onto a database. So we tend to have a separate system or a file storage system. This is where we use the S3, simple storage service, right? We tend to use a external system, which allows you to cheaply access data and retrieve it. So we can use a file storage system here. Now, eventually what happens is you have been able to manage load over here, right? We manage load here. We have some file system here. But now next problem is on our database. It becomes hard to, our database can get choked at a point. So what we do is we end up creating something called read replicas. So we can create copies of our database, and you can end up reading from a certain database. You can write to one database. The primary reason is, generally when it comes to most applications, you end up reading more than writing. So generally, like depending on application, you consume more data than creators, right? So the number of people who make a post per day is generally 20%, while the people who consume is 80%. So because of which you have separate databases for reading, and you have a separate database for writing. But what happens is, whenever you write, it will ensure it updates the other databases also. So the database will try to keep in sync between each other. So this is how you can add a read replica into your database. The next layer that can come in is something called a cache layer. Now, you would have heard of your RAM, right? People must have said, oh, things in RAM is much faster because it has a 2 KB cache or a 2 MB cache or 4 MB cache. So my system is faster. So similar to that, you also can add a cache layer between your database. Why? Because reading something from a database is not the fastest thing, because you can have, let's assume there is some information which you're asking everybody, right? Let's say everyone sees one certain information. Let's say 1 million users are requesting it every 5-6 seconds. So if there is a certain data which is being asked again and again from the database, you will end up choking it. So instead of accessing it from the database, we create an in-memory database, which means it's much, much faster to read it. So we always now check in the cache layer first if it exists. If it doesn't, then we fetch it from database. So this will also now improve your speed by a lot. So you have a separate cache layer. The final thing is that now we spoke about different regions earlier, right? So we spoke about that AWS has different regions that you can have data, or you can store your information. So what happens if you're trying to access some data from, let's say, US server or a website from the US? So we tend to serve a lot of static data, static images, all of this through something called a CDN. It is called a content delivery network. So you might think, how is Netflix, for example, being able to serve data from different parts of the world for users? So Netflix also has their own kind of a CDN network, which basically ties up with different people, and they end up storing more, let's say, Indian origin content on these servers. So that ease of access, because they might know people behavior, right? Like maybe you watch some certain regional languages movies, right? So they tend to store those in those servers. So similarly, CDNs basically ensure that your static sites, your websites, all of those small images, all of that is stored in these edge locations. So you could have it in India, you could have it maybe if you're from Africa, maybe from there also there might be a separate CDN. So instead of accessing it from the main server, it will go through a CDN. Now a CDN can be connected to your file storage also. So generally we don't expose this S3 directly. We generally use it through a CDN. So this way it is accessible at each and every layer. Okay. So far we kind of went through a simple example of how can you scale up an application. And I have not used or directly used any AWS services over here, but I've just shown you if you have to scale up your application, how would you have to go about designing a system around? Because as a next step, what we will do is we will get into specifics about how I can apply AWS services on top of it. Does that make sense? Anybody has any doubts so far? explain CDN again. So let's assume you are in different continents. Let's say this is Asia, or let's say this is India. This is Europe. This is US. So if you try to access data here, the amount of time taken is almost let's say 200 milliseconds, let's say. But if you access from here, it might be 10 milliseconds. Right? It might be 10 milliseconds. So instead of serving all the material from here, we put it at each and every location. So AWS gives you access to these edge locations, which are smaller servers across their regions. And it will deploy all of the static assets to all those regions. So we set out 30, 40 regions, right? So whichever is the closest region to you, you will be able to access the image or the material from there. Someone's asking about sharding. Sharding is a specific thing that we generally do for database partitioning. I won't be getting into that. It's a little more complicated, but it's around database partitioning as such. So what is a load balancer? So have you ever been to a metro station or a railway station where you have multiple counters? You have to buy tickets, right? What happens if there's only one ticket counter and there's thousands of people waiting in line? It becomes slow, right? So if you have only one, it becomes so slow because only one ticket counter is there. But what people tell is, instead of that, there's a police officer which says, okay, you go to the first one, second person goes to the second counter, third person goes to the third counter. So this is what a load balancer does. Instead of all the load going to one counter, you're distributing the load over there. Does that make sense? Okay, all right. So let's actually go to the next part. So we spoke about all these different systems out there. So I'm going to now take it one by one and going to insert AWS services on top. So the first thing that we saw, so we saw these web servers, right? So we are going to add our EC2 servers over here. So these are all EC2. So this is our first thing. Wherever there's a web server, let's go put our EC2 servers there. We already have a load balancer. It's the same logo, so I'm not changing it. The second is our S3. So this is our file storage service, right? Simple storage service. So S3 will be here. So if you want to access now any information from S3, you can directly access it from this. The next is something called Route 53. So we spoke about DNS, right? So Route 53 is basically mapping your domain name to the particular IP address that you want to access, or a particular service. So you can use this thing called Route 53. So this is what AWS provides for DNS mapping. The next is the CloudFront. CloudFront is what we use for CDN. Okay, so this is what we use for CDN, or content delivery network. So CloudFront has centers across the globe, and you will be able to deploy your websites in these small edge locations. So if ever you want to update your application or website, you will have to go and tell CloudFront also to update those. Otherwise, it will take 1 or 2 hours for different people to see the updates on the website, right? This is called invalidating a cache. So you'll have to go and tell CloudFront whenever you update a site or update some information on your static data, you'll have to go tell CloudFront also that. CloudFront can also act like a layer in front of S3 so that there is no misuse of S3 data. Okay. The next is for our databases. So we are just mapping our RDS over here. And relational database service comes on this right side here. So you can now access all of this information here. Once we have our database also mapped here, the last thing I would probably add is our cache system, which is called the Elasticache. So where we generally use something like Redis or something like that to also manage cache. So now we have another layer that we put in for the cache system. So this, so far, what you can see should give you a general idea of all the different services that you can get started with AWS. There are plenty more, because I said, no, we have like, there are 200 plus, and I don't think one company will use all 200. We ourselves have used at least maybe 10 to 20 different services there, depending on what and how, right? But why did we start with designing a basic website and then adding on to AWS? Because you need to understand AWS is a cloud service provider. So there are other systems like Google Cloud Platform. They will also have a similar offerings. So instead of an EC2, it might be called something else. So which is why I started with something which is not specific to AWS and then added these individual icons here. And these are just names that AWS has for their own services. So you can use similar services from other providers also. But what you need to understand are those terminologies. What is a web server? What are file storage systems? What is a DNS? What are load balancers? What is CDN? What is a cache system? What are databases doing over here? How do we do vertical scaling? How do you do horizontal scaling? All of this information. Now, once you do all of this, your system will be much more stable. It will be much more like scalable, and it'll be more available for your system, all of your users throughout. Right? So it makes our life much, much easier, like to handle applications like this day. You can start a company and deploy your web application sitting just at the comfort of your house. You actually don't have to go anywhere. And this is the power of AWS or any service provider in cloud. And I think as a developer in this generation, you should be able to pick up at least one cloud, because it's a very, I think, important skill to have. It solves a lot of problems. You can get a basic understanding of how to work with AWS from their own website. They have a lot of training information there itself. You can easily go through that and kind of figure. But what I would recommend is that you learn a bit of programming first, like create some basic websites, create some basic web applications, and then get into cloud, because this is also a huge industry of its own. But having a prior knowledge on programming and computer science and whatever, like building applications, will help you understand the importance of AWS a lot. And eventually you can take up certifications also on AWS, which is very useful if you're going abroad and you work for certain companies. But that's not something you should start with. You should start with basic development and being able to understand the services out there. Does that make sense? So I'm hoping you have a general idea of what is AWS, what is cloud computing, what are these services that go on the background, because a lot of these things you cannot physically see, right? You need to visualize and understand. So Yeah, so Prashant, I think that's it from my side. But I think I'd be happy to take up a couple of questions if required.
Guys, if you have any questions, you can write in the chat box. Albert will be taking your questions and guiding you with the same.
Yeah. I do understand the
For
topics.
details.
I do understand the topics a little high level in nature, but generally when it comes to cloud services, it is supposed to be a little high level. Masai start AWS course. It is a part of your development. It is as a developer, this is something you use. So if you are in our probably a backend developer programs, towards the end we do cover AWS. Actually, next week we are teaching one of the courses, AWS itself. AWS is a part of it. It won't be the only thing we do because we are into more into creating developers, not just cloud engineers. What skills should we have to become good cloud developers? One is a good logical understanding of systems. Like you need to understand what systems are, getting comfortable with terminologies in computer science. You need to go read about it. Go and try things out. I think that's the best way you learn a lot of things. Go and build things. But I think start small, start simple, start with a simple website. Understand what a website is, understand your internet, how the internet works. I think that's a very fundamental thing, I would say. Understand networking, understand how these systems talk to each other, what APIs are, and then kind of build on top of it. Because what AWS solves is for you to deploy applications as such. For data engineer role, what do I need to? I think if you're going to be in data engineer, there are 2-3 levels to this. Completely different set of services are there for data engineering. Again, depends on, are you looking at data analytics, data science, machine learning, or are you looking at database management? There are different services for that. If you're looking at around data analytics and data pipelines, AWS has a lot of things for creating pipelines of combining data from multiple inputs and then joining it into one place and then creating a pipeline of data. And then a lot of your analytics and engines can work on top of it. But it depends on where you get into it. There's an interesting question out there. Who is the best? Is it ethical hacker or a full stack web developer or a backend developer? I don't think anyone is the best. Everyone has different skill sets, and they work together actually. So people work together to build the best products. So you can be good in certain domains. You can be an excellent front-end developer. You can be an excellent backend developer, but you may not know other domains, right? So people come together to solve problems. So we generally have a pod structure within software development. What skill certifications are required for DevOps? DevOps, by the way, what I mentioned here is all just parts of development. So if I were to bring up this, right? Let's say you want to update your website. For me to update my website and kind of update the applications here, it will probably take a couple of hours at least for this architecture. If I want it to be immediate and automated, then I generally tend to write, like you will probably be a DevOps guy. Or if you have a much more complicated systems, then you have DevOps creating automated structure there. So it's developer operations. So when we have to update a website, if it's too complex and too operationally heavy, we tend to write automation scripts around it. And these people are generally called DevOps. A cache, what does a cache mean? A cache is nothing but, so let's say what is 2 plus 3? or maybe 500 into 2, right? Or maybe 33 into 5. What is 33 into 5? We can say it's 165, right? So now you remember 165, but if I say add 2 to that, you will say it's 167, right? But you do not have to calculate 33 into 5 again, right? Because why? It's in your memory. It's in your memory, right? It's in your recent memory, because you just made a calculation now. You're not trying to do calculation again. So a cache is something like that. You are keeping most recently used items in memory, so that it can be accessed later. So you don't have to keep remembering it, right? So I'm going to hand it over to Prashant, because I think we have a time limit to keep to. So Prashant, over to you. Shall I stop the screen share?
Yes, please. Yes. So thanks a lot, Albert. It was very insightful. Even I myself was making notes of some of the concept which was not clear during my college time. And I think cloud has become a lot fun after like attending this session. They would have understood what cloud actually is and how AWS is helping in making our lives better. Guys, now I will be taking some of the questions from admissions, and I will be telling you something about Masai school. And then finally, we will wrap it up. Thanks a lot, Albert, for taking this session. And I'm sure that it would have helped a lot of them.
Thank you, Prashant. Have a good day, everyone. Thank you. Bye.
Perfect. So now we will again move to Masai School admissions, and talking about the progress so far we have done. So we were started in June 2019, 16 batches graduated, 18 batches running. We have 1,500 plus graduated students. Currently, we have 6,000 plus students that are pursuing this course with us. 2,000 plus hiring partners we are currently having, and also overall 94 plus percentage placement ratio. Last 13 batches have it for 100%. So you can understand the result that we are giving. Average CTC is around 7.2 LPA. So now if we compare our courses full-time and part-time, so it is very simple in here. We have currently 3 courses that are with us. One in full-time, 2 in part-time. First one is full stack web development full-time. And then we have full stack web development part-time. And then the third one we have is part-time data analytics. Talking about the duration for all 3 courses is 35 weeks. For data analytics, it is comparatively lesser. But again, if you go into revision, for this also it is 35 weeks. Talking about the class timing for full stack web development full-time, it is 11 a.m. to 11 p.m. Monday to Saturday. For part-time full stack web development, it is 8 p.m. to 11 p.m. Monday to Friday, and Saturday 10 a.m. to 5 p.m. If we talk about part-time data analytics, it is 7 p.m. to 12 a.m. Monday to Friday, Saturday 3 to 10. Talking about eligibility, very simple. If you want to go for full stack web development full-time, you should be at least 12th pass and your education should be complete. You should not be a working professional. Then you're eligible for full stack web development. Now our timings are changed. You should be available for 11 a.m. to 11 p.m. 6 days a week. For part-time full stack web development, students who are graduating in 2023 and they should be a working professional. This is the eligibility. I think there is some typing mistake in the presentation. So students who are completing their education in 2023 or a working professional are eligible for our part-time programs, whether it is web development or data analytics. Talking about the course fee, so it is 3.5 lakhs inclusive of GST for full stack web development full-time. For full stack web development part-time, it is 3 lakh inclusive of GST, and for part-time data analytics, it is 2.5 lakhs inclusive of GST. Talking about the curriculum, so for full stack web development full-time and part-time, it is full stack web developer or MERN stack development curriculum. And for part-time data analytics, it is analytics and data science. Also, very important thing, students should be ready to take up the job immediately after completing the course. If you have any doubts, any queries, you can shoot in the chat box, or else we will wrap this session. Perfect. Great. I don't see much of the questions here. If you guys, if you have any doubts, any queries, you can write to admissions@masaischool.com or attend our Q&A sessions Monday, Wednesday, Friday. I hope that this session was very helpful for all of you. And I hope that Masai can help you in shaping your career. All the best for your future. Thank you for attending this session. Have a great day. Bye-bye.